Welcome back to Hoochos. 3D printing is now a tool. That is the major leap, I believe, that has happened in the 3D printing space within the last year. The technology has evolved from something that is exclusively available to tinkerers and hobbyists and has now become accessible to the larger population. In this video, we are going to explore my printer recommendations for the channel. Specifically, we will be looking at these. These are the Bambu Lab P1S and the Bambu Lab X1C. Two offerings from Bambu Lab, which I think are appropriate for printing all of the objects that I create. All right, let's change up set for a second. So if you're unfamiliar with this channel or my other channel, All the Gear, I create practical prints that people can use at home to enhance their life in practical ways. So to me, a 3D printer is a conduit in a workflow that moves from idea in my head to computer and then passes through the 3D printer, which materializes it in real life. Now, if that isn't magic, I don't know what is. The moment that I started 3D printing, I realized the potential of this technology going forward for everyone. This is going to become an appliance that is in every house, just like a microwave. Now, the main limiting factor in this workflow is generally the 3D printer. It restricts time, it restricts material, and it restricts shape of the idea that you're trying to translate from computer screen to reality. Now, as far as I'm concerned, any technology that removes those limitations, reclaims time, and streamlines that process adds productivity to individuals and society itself. And that is why I'm focusing on these printers today. So here I have the Bambu Lab P1S, and I'll tell you how I got to the decision of purchasing this printer for myself. A couple of years ago, I made a video on the Enders, and this was kind of like a channel guide video on how to 3D print, as well as how to troubleshoot 3D printing, how to replace parts. It was basically a complete teardown of the Ender and how to manage it, print settings, and the rest. Now, this guide to 3D printing, it's kind of a good summary of where 3D printing was a couple of years ago. The focus wasn't on the 3D printer's capabilities, it was on how to manage the tool, because the tool in itself took up a lot of time. So when I started seeing the reviews of the Bambu Lab printers come out and how they have created a plug and play 3D printer, I couldn't resist. I went out and I bought myself this. This is the Bambu Lab P1S, part of the P1 series that steps up from the P1P, which is a non-enclosed device, to something similar to the X1C, which we will be exploring in a little bit. When I received this machine, I started using it, and I realized very quickly that this machine is incredible. Now, I will say, I was stepping up from Enders. The contrast was stark for me, but I was so excited by the prospect of presenting the people in my audience this printer as a solution for plug and play printing that I reached out to Bambu Lab. So for complete clarity, I'm just gonna read out the email that I sent them so that you understand the perspective that I was coming from. Hello Bambu Lab's marketing team. I'm a 3D printer, hydroponics and gardening YouTuber. I have recently purchased your Bambu Lab's P1S, and to be frank, I love it. I want to recommend your product to my audience, and I think this is an opportunity for us to cooperate. I want to move away from the 6 Ender machines that I have in my prototyping lab, and I am interested in exploring the carbon and AMS combination, as well as the mini, to see what the best option is for my viewers. A string of emails went back and forth, culminating in them sending me this. This is the Bambu Labs X1C with AMS combo. So I've spent the last couple of months playing around with both of these machines, and I have come to many conclusions which I now want to share with you, recommending either the P1S or the Carbon, respective of who you are and the outcomes you want from machines such as these. So let's compare and contrast these machines. Now, the reason that I was so interested in playing with the X1 Carbon is mainly because of its multi-material capabilities. However, we are going to explore how the P1S can actually be upgraded to do the same. The thing that I didn't expect is that all of the other features within the Carbon would actually have a greater effect on the experience of uninhibiting my workflow. It's also allowed me to incorporate multicolored prints into that workflow, which is expanding my design capabilities. And to be completely frank, the AMS is able to be fitted to the P1S. So what's the difference between these two machines? And why would you pick the Bambu Labs X1C over the P1S if it's technically capable of all the same things? Well, that's actually what I'd like to compare and contrast in this video to give you the best information on your purchasing decisions when it comes to my recommendations for a 3D printer on this channel. Now, both these printers are incredibly fast. On my enders, I had exclusively 0.8mm nozzles to reduce print time, and I actually ordered a 0.8mm nozzle with the Bambu Lab P1S and never fitted it, because the moment that I started printing with a 0.4mm nozzle, the print time was cut by 2/3, and that is just. I went from 12-hour prints to 4-hour prints, and from 24-hour prints down to like 9-hour prints. The funny thing is actually, they have sport like modes where you go from silent to standard. Standard is like default mode, and then you go to sport, and then you go to ludicrous. But even their standard mode is what I would consider ludicrous for something like the old Enders or even the upgraded Enders. I know that I'm going from like archaic technology to state of the art, but my God, they are fast. 20,000 millimeters per second of acceleration. This speed is driven by its high speed Core XY design. Both of these printers have a welded steel chassis, multicolor and multi-material capability utilizing the AMS module. Direct drive extruders, which actually in my experience are super powerful. I had a lot of problems with filament getting stuck on the filament rolls as the filaments end. Even if you have a filament sensor, if those drives aren't strong enough, have enough grip on the filament, they won't pull that filament through, and you'll have print failures even with a filament run out sensor, because they'll just grind away at the filament until such time as the filament snaps or it just doesn't pull through and you get a print failure. I've never had a problem with these drives not pulling the filament through. It also has a filament run out sensor, so you can use whole spools of filament and then just reload mid-print. Both of these machines have carbon filters integrated into the fans within their bodies. This is good for printing materials that give off VOCs and allows the printers a wider range of materials in a safer manner. And they both have active vibration compensation, which is essentially an algorithm that compensates for the movement in these machines, and there is actually quite a lot of movement. The speeds the head is getting up to is actually mind-blowing, and there is some wobble in the machines, and that is just physics. I'll also say that they aren't the quietest machines. Coming from an Ender, I mean, they're the same, but I have had the Ender 3 Pro Max Neo. It was incredibly quiet, but it wasn't moving at these speeds and it wasn't achieving the results that these printers are achieving. So no, you will not be able to have this in your bedroom and sleep with it, but I am more than happy to make that sacrifice. While we're on the negatives, I guess, walled garden, so very much like Apple in the sense that they're a proprietary brand, there's no open source, but I'm also an Apple fanboy and I understand that to make something work as well as these machines, you kind of need everything to be proprietary to work together in an ecosystem. Another thing that I haven't seen mentioned in many reviews is that the bed isn't actually a 256 by 256 by 256 square. It has an exclusion zone in the left-hand corner, the front left-hand corner, which you cannot print on. Technically, there is a workaround. The reason is on the side of the head, there is a lever that the head will push up into the corner and press against a protrusion in the corner of the printer that cuts the filament, which allows the AMS to operate because it will then pull the filament out, push other filament in, extrude out the tiny amount of filament that was cut, and continue printing after it has stacked its color. That means that your designs are restricted to the rest of the print bed, which I've actually found to be a problem when I was designing something that kind of needed the whole print bed. There is a workaround in the sense that the protrusion, it's on a spring. You can push it back, and because it's on a spring and you can push it back, there is a print that you can print that holds that protrusion back and allows you to utilize the entire bed. However, it does remove that ability for the printer to cut its own filament. It means you cannot use the AMS while the exclusion area disabled. It is something to be aware of if you're planning on printing something that is exactly that square size. And we'll talk about that object that I was trying to print in a little bit. All right, so let's talk a little bit about the differences between the Bambu Lab P1S and the Bambu Lab X1 Carbon. So on their site, Bambu's definition of the differences between the P1S and the X1C is: the P1S is based on the P1P with an improved cooling solution and enclosure. However, it is not recommended to directly print fiber reinforced filaments such as glass fiber or carbon fiber before an extruder and hot end upgrade. The X1 Carbon is equipped with micro LiDAR for advanced AI detection functions and offers more convenient and efficient screen interaction. Now, I'd say that's a pretty good summary, but we can go more in depth when it comes to the differences. Now, having operated the two of these in parallel for about a month and a half, I'm going to outline the differences that I've found between the two and the surprising conclusion that I came to when it comes to which one I would recommend. The differences are: the X1C has a flow calibration area as well as a nozzle L wipe. So the wipe on the P1S is where the flow calibration would be in the X1C, and there is an L wipe up in the corner, which is essentially just a nozzle wipe in a different place. The X1C has LiDAR, which allows for all of the extra bed leveling functions the P1S has in a physical bed leveling function, where the nozzle touches the surface, but the X1C has in a physical bed leveling function, as well as the LiDAR, which gives it an extra level of calibration. And the LiDAR also allows for a first layer detection, where it scans the first layer and looks for abnormalities within that first layer. They both have time-lapse cameras. The P1S has a 720p time-lapse camera, and the X1C has a 1080p time-lapse camera. And as far as I can tell, this is a much better quality camera, and when you're actually accessing the camera in the app, this camera works, and I'm not sure whether this is the Wi-Fi module being more efficient or the camera being more efficient, but it is a non-stuttering picture on your phone, whereas the P1S stutters a lot. The connection, it just falters, and it's a slideshow of pictures from the printer rather than a video, which I get from the X1C. The 1080p camera in this allows AI, or machine learning, to detect spaghetti and other malfunctions similar to that. Now, my experience with this is actually that the printer tends to err on the side of caution, and it will actually fail the print. Not fail, but it will pause the print way more often than this machine, because it will essentially find false positives or false failures. Sometimes that can actually be a point of frustration with the device, which is just silly that we've got to the point that a device is more cautious than you are. But it has actually saved a couple of my prints. The continual updates that I've been getting for this device, and the way that I see really edge case scenarios handled by it, especially with the AMS unit. Recently I had that problem where filament wasn't coming off the spool, and the AMS unit basically solved the problem itself. It just kept running until it solved that problem. And I was just standing there in awe that this machine has such an edge case built into its programming. It is very impressive, actually. Another difference is, this is just a software thing, you actually have access to the time lapses in the app on your phone with the X1C, and you don't with the P1S. I'm not sure why that is. Now, these are differences that I don't really get. The X1C has a door sensor. It's integrated into the door, but it's not functional, I don't think. As far as I can tell, it doesn't have any function. There is a spot for it on the P1S, but there is actually no physical sensor in there. So that doesn't really matter, but that may be something that they integrate into the future. And weirdly, the X1C doesn't come with an SD card to record your time lapses, and the P1S does. So because I got the X1C after the P1S, I spent probably like half an hour in that box looking for the SD card, because I thought it's a more expensive printer. Of course it's gonna come with an SD card. The other one did. Nope, I had to look online, and everyone says I couldn't find my SD card, and that doesn't come with it. It's not in the list of things you get with it. It would be nice if this rather expensive printer came with a small 32GB micro SD card, but it does not. So, okay, so those are the differences that aren't really upgradable. You can't just add them onto your P1S. Now we're going to get into, well, the main differences and the upgradable differences. The X1C comes with a hardened steel nozzle. Now that means that it can print carbon fiber and glass fiber filaments. The P1S comes with a stainless steel nozzle. Now that can print in those filaments, however, it's not recommended. Now you can just upgrade that to a hardened steel nozzle. Now, the X1C also comes with a metal gear extruder. So this is also part of the caveat of printing the fiber reinforced materials. You need hardware that is hardier. So to print with these materials, it is recommended that you also upgrade the metal extruder gears for carbon fiber and glass filament. Both of these upgrades are things that I would recommend to people choosing the P1S going forward. I specifically on this channel and my other channel want to start focusing on structural prints, especially on prints that are going to be utilized in vehicular storage, camping, and other lifestyle prints that I'll be focusing on all the gear. Now these upgrades are not expensive. The cost of upgrading both the hardened steel extruder and the all metal gears is only 56 Australian dollars. That's not prohibitive at all. And this is where we kind of get to contrast and compare the machines for those that are looking at both of these options as a printer going forward. The cost of these printers at the time of the making of this video was $1,069 for the Bambu Lab P1S and $1,839 for just the X1C, not the AMS unit, just the X1C, which makes this printer about $800 cheaper. With the cost of upgrading to the multi-material, which is about $56, you're looking at $1,124 for this machine with the print capabilities, not all the fancy stuff, the print capabilities of this machine. That's a saving of about $700 to $750. And that is going to drive a lot of people to the P1S. However, I'd like to talk to you for a second about the main differences between these two offerings from Bambu Lab. Now, they both print from device. You can utilize the screen on this, or you can utilize your smartphone with the smartphone app. Now, the smartphone app is actually incredible. It's quite intuitive, and it does somewhat replace the screen on the X1C. However, the ability to just come up to your printer, tap in, select a file, an older file, and print, it is a quality of life upgrade that I did not expect that would streamline my workflow in the way that it has. The immediate feedback that I get from this screen with troubleshooting and the integration of the AMS specifically, which we'll talk about in a second, as well as the deep printer control that you can achieve at the printer with this, it brings a level of ease to printing that I found was actually a little bit of a hurdle with utilizing this screen, and I found myself hesitant to control this printer with this screen. Obviously utilizing the phone app all the time as well as the computer rather than even going near that thing. I know it's like I'm a spoiled kid, but like this is just so good. There is one thing within this programming that they have added since a lot of the past reviews, and that is bed object omission. So if you have a print failure on your print bed, you can actually enter into the software and it gives you a G-code rendering of a top-down view of your bed. And this actually allows you to select objects on that bed and omit them, so that say you have 6 different objects printing and 1 or 2 have failed. You don't have to fail the whole print and just start again. You can omit objects as long as they're not touching, and the printer will just skip those parts of the G-code. And this is incredible. If it detects a print failure, you can just continue the print, omitting the objects that have failed. That's like magic. Anyway. I think this is yet to be realized by Bambu as to the potential that it has going forward in the future with updates. In fact, I'd like to take a second right now to talk to Bambu Labs. Here is a way that you can improve your customers' lives at the same time as diversifying your sales of both of these devices. I would like to see implemented in the future the X1C's screen have the ability to control multiple P1Ss. If I could purchase one X1C as my first printer and then know that I can expand my printing capabilities by buying P1Ss that would be controllable from this screen in a prototyping or print farm facility, I would buy a X1C without question as my first printer. And then you could have add-on printers that you upgrade the hot end and the extruder gears, and all you would need is a tab on your X1C that allows you to control an array of printers. This would make existing P1S customers more likely to buy the X1C, and it would also make X1C customers more likely to purchase quantities of P1Ss to fulfill their prototyping facility. And then each print farm would have multiple groups, multiple X1Cs, and an array of P1Ss that are controlled by those X1Cs. I think it would be a beneficial move for both your business and us. All right, so let's quickly talk about the AMS. Okay, so at first I thought multicolor printing, like it's just a gimmick, it's wasteful with filament, but that is actually before I started designing my own multicolored prints. And the reason for that is every print that I had ever seen on YouTube had been a toy, essentially. There's not many people that design functional prints. And when I started designing my prints with function in mind, I started to appreciate the usefulness of multi-material as well as multicolor prints. For instance, here I have a functional print that is about to be released on my second channel. It is a lockable vehicular storage. It allows you to store fishing rods and other long items on a vehicle, which is lockable and sealed so that you can store things safely on a vehicle. Now, I needed these to be extremely strong, so I needed to print them in materials that are versatile and suitable for the application. And going forward, that is what I'm going to start incorporating into my channel. Efficient color and multi-material 3D prints that utilize the AMS in a way that we can affordably incorporate the color and physical attributes of multi-spool printing. Now, this might just look like a couple of my logos that I've created as an example for this segment, but these are actually functional. One of the downsides of the AMS is that it does not accept cardboard spools. And these cardboard spools are the cheapest PETG that is available to me in my area, which is Australia. The problem is that the AMS module, because it is a fully self-contained module, it spins the spool in the holder and the cardboard disintegrates essentially because the edges of the spool aren't what usually is meant to be touching. Usually it would be held on a spool holder. The cardboard disintegrates and clogs up all of the moving parts, and it's a bit of a problem. So I designed these. They're essentially just spool protectors and allow the spool to run on the runners within the AMS. And I designed spool protectors with my logos on them, and this allowed me to test out the color printing. Now these just fit directly over the top of our cardboard spools, like so, and clip into the center hole as well. And they allow you to protect your AMS unit from cardboard spools. So for those who have access to the JO filament in Australia, I'm going to put these designs onto my Patreon. There are multiple. There are less filament hungry ones, which I've designed so that they have cutouts in them, or you have the option of testing out your AMS units with multiple of my logos. Now this was printed in the Bambu Labs PLA and my cheap PETG. I'm really impressed with how vibrant the Bambu Labs colors are. I've never actually been able to get a color that vibrant. So thank you to Bambu Lab for sending those out to me. And here is the print that I was talking about earlier that actually takes up most of the print bed. And as you can see, I've got my logo down there in the corner as an example of how much filament this wastes. That is the color stack for this print. It is not very wasteful at all if it's designed properly, and that's what I want to talk about with you right now. That is actually an upcoming design on my channel that I've printed for a Kratky bucket lid. And the reason that I needed it to be so large is because the print surface is not the size of a bucket, but this design can actually fit over a bucket, which is pretty cool. And the tolerance that these printers allow me to design in is just incredible. Like, I think I've got a 0.2 millimeter tolerance on these, and it just works. Like, look, moving parts. How good. Something that I don't see anyone talk about is how to design for the Bambu Labs AMS. And I just want to touch on that quickly while we are looking at the AMS. So essentially what this system allows you to do is it allows you to have multiple materials and multiple colors print within a single print file. And the way that you achieve this is you go into the Bambu Labs slicer, which is essentially just a Prusa slicer skin, where they've done a lot of work to make all the print settings absolutely perfect for their machines. So I'm not even going to talk about print settings here because just use their print settings. That's the beauty of these machines. It's plug and play. You put your model in and you print it with the print settings for the filament that you're using and it'll just print it. It's incredible. But when it comes to multi-material and multi-color, you need to design the designs essentially so that you can easily and quickly throw them through a slicer and then paint them with the colors that you want to achieve. So for instance, when I designed this, because you want it to be able to be printed for people that do not have an AMS, as well as people who do have an AMS, you design it so that it can be. So there's not two separate files that you're dealing with and that everyone else has to choose between. The way that you do this is when you're in the design program, when you're in Fusion 360 or whatever you use, you take the design, and this is for any surface, but realistically, if you don't want to waste too much filament, this is mostly for the top and bottom surfaces of your designs. You emboss or extrude into the surface that you're going to print or the top of the surface that you're going to print, whatever shape or words in text or whatever that you want to be colored, you emboss it by 0.02 millimeters. So that's 2/100ths of a millimeter. It's enough for the slicing program, the Bambu slicer, to register that there is imperfection on the surface, but the slicer will actually ignore it for printing purposes. So for people that do not want to print in multicolor, it does not show up on the final print. But for people who do want to print in multicolor, you can go into the paint surfaces section of the slicer and you can fill paint these areas with different material selections or different colors essentially. And this allows you to fill in color and print in incredibly detailed arrangements. And if you didn't want to do the fill print because there's just too many letters or whatever, you can print by layer. And that will allow you to select everything that is on the same surface. So in that 0.02 layer, it will print everything in white, like this. And that allows you to like multi-select a whole surface of intricate designs if you didn't want to individually click and fill all of those areas. And it prints it as if it were on the first layer. So that it doesn't print on the second layer or the third layer. It will print first layer in 2 different colors or however many you want or however many you like, and it will print perfectly. So that's just a quick design consideration for if you're using the AMS. These will be on my Patreon if you want to print them, and I hope you enjoy them. Okay, so back to the printers. I just want to mention the A1 for 1 second because I do think that that is a very affordable option for people that don't quite need all of this. The A1 Mini I probably wouldn't recommend for my viewers because I will be designing with these bed sizes in mind, so you may miss out on some larger prints that take advantage of that larger bed size. And I would actually like to get my hands on an A1 to give it a bit of testing. So let me know in the comments below if that's something you'd be interested in watching. When it comes to the P1S and X1C, however, they got me. In real life, after watching all the reviews I could get my hands on, I chose the P1S. And this is the right choice if you're willing to sacrifice workflow, but still have an identical print quality and be able to upgrade to the multi-material capabilities of the X1C. However, for me now, if I were to repeat this purchasing decision, I'd actually choose the X1C for the control that the screen enables and my workflow. It allows you to change AMS filament with extreme ease, and if you want the true unencumbered printing experience that Bambu Labs is offering, this is the way. Essentially what I'm trying to say is these printers are two different answers to two different people. The pragmatic value hunters and the my time's worth too much and I'll pay anything to remove obstacles in my workflow. Now personally, I'm both of these people. Naturally, pragmatically, I am the first, but I've been falling into the second as my time becomes more and more valuable to me. My time is worth money, and this is no longer a hobby, it is a business. Personally, I actually think that Bambu Labs has done right by the 3D print community by offering the P1S and probably cannibalizing sales of the X1C. And they've done that just to give us the ability to choose between pragmatism and luxury, or in a more pragmatic view, a fluidity of workflow. So I guess I'll just leave it up to you to figure out which one of these people you are and make the choice that best suits your situation. Happy 3D printing, and I'll see you next time on Hoochos.